Hi everyone. Rosie, Tipsy, and I are back at it again today. The topic for today is using trig in order to find angle measure, or something called inverse trig. So up at the top of my page, I'm going to title this Using Trig to Find Angles. And some people might call this inverse trig. You're going to hear me use this word inverse a lot in our lesson for today. All right, we use inverse trig to find angles. That's really, really, really important. Up until now, all of the work that we've been doing has been in finding sides. But today we're going to bump up our knowledge and our understanding to the next level, and we're going to talk about using inverse trig to find angles. So you might say, well, what is inverse trig? What does inverse trig look like? So inverse trig is going to be very similar to your sine, your cosine, and your tangent that you've seen before. But inverse trig is going to have in the upper right-hand corner this little -1. So again, see the little -1 that's written above and to the right? That's inverse trig. We're going to use that to find angles. Not to be confused with our plain old sine, our cosine, and our tangent, our old familiar friends. We use these fellows in blue to find sides. So if you're finding angles, you're using these inverse guys in the calculator. If you're finding sides, you're using our plain old friends sine, cosine, and tangent. And we'll talk a little bit about where to find those new friends, the inverses in the calculator, but let's go ahead and let's look at an example. In example 1, I'm going to say that if we know that the sine of some angle, I'm going to call it angle A, for lack of something better, is equal to 3/5, can we find out which angle has that sine value? So in other words, find the measure of angle A. So again, if we know the sine value of some angle, can we work backwards in order to find its angle measure? This is what this is all about. So inverse trig is going to be used to undo taking the sine of an angle. So the way this is going to look in our notes or in our problem solving is we're going to do an inverse sine of the sine of some angle. And remember back to when you first learned to solve equations, if you do an inverse sine on the left side, you also have to do an inverse sine on the right side. Because in rule number 1 of equation solving is whatever we do to one side, we have to do to the other side. And I want you to think about inverse sine and sine as operations that undo one another. Kind of like we can undo squaring a number by taking its square root, or we can undo adding 5 by subtracting 5, or we can undo multiplying by 10 simply by dividing by 10. These are all inverse operations. So I think about inverse operation as the undoing operation. The inverse operation for multiplication would be division. The inverse operation for subtraction would be addition. So it's the undoing operation. Why this is helpful is because inverse sine and sine undo each other. They eliminate each other from the problem, and we're just left with A. So A now is going to be equal to this inverse sine of 3/5. And I'm going to calculate the inverse sine of 3/5 on my calculator. I think I'm going to go open up a new document just to clean things up. And this is where you're going to find inverse sine. You're going to find inverse sine in the same spot you find sine, cosine, and tangent. So here's our friend sine, cosine, and tangent that we've been using to find sides. But now we want to use inverse sine. So here's inverse sine, here's inverse cosine, here's inverse tangent. So we want inverse sine of the fraction 3/5. And the angle whose sine value is 3/5, we're going to round all of these in this video today to the nearest tenth, is 36.9 degrees. So again, kind of a big key idea. If we're finding angles, we're using inverses. If we're finding sides, we're using plain old sine, cosine, and tangent. All right, I'm going to scroll down and take a look at another example. So I'm going to say we've got this right triangle. And we know that one of our legs measures 25 and another leg measures 20. I'm going to label this triangle ABC. And let's just suppose that the question wants us to find the measure of angle C. Well, the first thing that I notice is that we're finding the measure of an angle, so we're going to need to use inverse trig. But first we need to set up our equation. And to set up our equation, we're going to use our old familiar some old horse caught another horse taking oats away, or so katoa. And again, if you have this on a sticky note, it's going to be super helpful. Just take your sticky note and move your sticky note from page to page. So I'm going to once again start by labeling my hypotenuse. We're trying to find here the measure of angle C, so I'm going to call that x. So my opposite now is going to be the 25, which means my adjacent is going to be the 20. So I need the opposite in the adjacent. I want to use the trig ratio that deals with opposite and adjacent. This is a tangent question. So the tangent of my angle x is going to be my opposite side, which is 25, over the adjacent side, which is 20. And again here, I'm solving for an angle. I want to find an angle. So that's what tells me that I'm going to have to use inverse trig. So I undo taking a tangent by using an inverse tangent. So I've got inverse tangent of that tangent of x equals the inverse tangent of the fraction 25 over 20. So again, my inverse tangent and my tangent cancel each other out, and I'm left with x. And on the right side, I've got inverse tangent of 25 over 20. So I'm going to go to my calculator and I'm going to enter inverse tangent of the fraction 25 over 20. And I find that the measure of that angle is about 51.3 degrees. I love this. Rosie and Tipsy say it's so much fun also. All right, I'm going to move up to the top of another page. If you have room on this page, you're more than welcome to keep right on working. But I've got a third example, which I'm going to call example 3, real original, I know. And I've got another right triangle. This right triangle I'm going to call XYZ. And I'm going to make the right angle up here at the top, and that be angle Y. I'm going to make side XZ be 13 and side YZ be 5. And I think in this question we're going to find the measure of angle X. And that'll keep things nice and convenient because we can just label that with an X. So this one too, we're finding the measure of an angle, so we're going to use inverse trig. And again, we'll be using inverse trig in order to solve that equation. But that equation we're going to get by using our SOHCAHTOA, our some old horse caught another horse taking oats away. So I'm going to go label my triangle. My hypotenuse, remember, is opposite that right angle. So this picture's drawn a little funky. My opposite is going to be the side opposite the angle that I'm trying to find. So opposite is going to be 5, which means my adjacent is going to be side XY. So in this question, I've got hypotenuse, I've got opposite. I need to go find trig function that deals with opposite and hypotenuse. I'm going to use the sine function in order to set this equation up. So sine of my angle, the sine of angle X, is equal to the opposite, which is 5, over the hypotenuse, which is 13. And again, I'm finding an angle here, so I need to use my inverse trig. So I've got inverse sine of sine of angle X equals inverse sine of the right side, which is 5/13. And again, the inverse sine and the sine undo one another. So they kind of knock each other right out of the problem, which means that on the left side I'm left with X. On the right side now I can go punch inverse sine of 5/13 into my calculator. So 22.6. And this is an angle, so it's in degrees. If I want to put a little degree sign there, I can, but I don't have to. Beautiful. This is so much fun. I love this. And you folks are advancing your trig knowledge. It's going to help you so much in Algebra 2. It's going to help you when you get to your SATs and your ACTs. I'm so proud of you for sticking with this and persevering throughout the distance learning. Good for you. All right, one more. This one, surprise of all surprises, I'm going to call example 4. All right, so for my triangle, for this one, I'm going to draw this one a little funky too. This one I'm going to label triangle ABC, and I'm going to make the right angle angle C. I'm going to make the hypotenuse AB. And I'm going to make AB 5. I'm going to make AC 3. And I'm going to say for this one, let's find the measure of angle A. Again, we're finding an angle, which tells us we're going to have to use inverse trig. And I've got some old horse caught another horse, taking oats away, or my so katoa. In this question, opposite the right angle is 5, making 5 my hypotenuse. I'm trying to find here the measure of angle A, so I'm going to call that x, which means that the side opposite from x is side BC, making 3 the adjacent side. So I've got hypotenuse and adjacent. I need to go find the trig ratio that deals with hypotenuse and adjacent. So I'm liking the trig ratio for cosine for this one. So cosine of angle x is equal to the adjacent, which is 3, over the hypotenuse, which is 5. And again, I'm finding an angle. So now to solve this, I'm going to use inverse trig. So on the left side, I've got inverse cosine of that cosine of x. On the right side, I've got inverse cosine of that 3/5. So again, inverse cosine and cosine cancel each other out, leaving us with just x on the left side. And on the right side, we've got that inverse cosine of 3/5. Making this about 53.1 degrees. All right, so to practice this, you've got a castle learning. And if you bump into trouble in the castle learning, you can always come back to your notes. You can always email me. You can email Miss Andre. You can join our office hours. We'd be happy to Zoom with you if you think that would be helpful. But you've got all sorts of ways that you can reach out to us if you're struggling with this, because we know it's not easy, but we want you to know that we're in this together and we're here for you. So the castle learning assignment is going to be castle learning number 5. And it's called using trig to find angles. Tipsy, Rosie, and I, we had so much fun here with you today finding angles. And we'll look forward to seeing you the next time.